So in this video, I want to show you how can you convert your Excel data file into SPSS. So this is very straight process. So I'm going to show you a data file which I received from one of the student, Eliza, and he's doing a project related to COVID. So he and his team members collected some data about COVID from publicly available sources, and I'm going to show you what data file I received from Eliza. So what you see right now is a data file which Eliza prepared, and you see that data file is very simple data file, and he didn't use any kind of funny characters or any kind of a color coding. So it's look like a straightforward, so this is the starting point of creating data files. So if you have Excel data file which looks kind of funny, so make sure it should not look funny. And one more thing I want to show you is this, is if you see the very top row, and top row obviously is your name of the variables, and what I like about this data file is, and there is also a variable list created here. You can see that. So these are the variables with Eliza used. Okay, for example, if you look at the data here, so this is a country, and so variable name is country, and the label is country name, right? And if you again look at it said GDP last, and then if you look at the variable, it's called GDP per capita USD billions last, right? So the point of this variable name is that the variable doesn't have to be very large names, okay? And also when you bring variables into statistical programs, they don't like long variable names, they like short variable names. And one more another important thing is when you bring the variable, when you create variable name, you notice that none of the variables have the space. Okay, so what I would suggest you do is just you look into Excel data file and create something like this. So these are the variable names. You see these variable names, they don't have a space, they're short, relatively short name, but you can have a big variables. Okay, and I'm going to show you what does it SPSS look like. So this is SPSS program. So this is a data view. This is in this sheet we're going to bring up the Excel data file, and this is a variable view, and you see that the first column is the variable name which Eliza has, and this is labels. So we can practically copy and paste the labels here. All right, and before we bring the data set here in, I just wanted to quickly go over one more time. If you look at the data set, right, make sure in your data set there's no funny characters are here. And I also like what Eliza has done. He's practically all the variables are coded. So of course you can see that some of the variables here he coded 0, 1, and if you look at the variables in the variable labels, he also provided descriptions. He said R, for example, marks political. So description is the variable label is R marks a political issue. Is there an anti-marks movement? So 1 is yes and no, and 0 is no. So when you see this one, so Eliza already know that he has these codes where 0 mean no and 1 mean yes. So he has coded them as well, for example. And if you look some of the variables with Eliza he has COVID death rate, COVID recovery rate, total number of COVID's cases and death cases, and these are total cases of COVID, for example. So I believe these are the variables Eliza would be using as a outcome variables, and other variables Eliza would be using as a explanatory variables, or your so-called your independent variables. Okay, so one other way you quickly find out if your variables are numerical variables are okay, what I normally do is just a quick run is this, I simply quickly run an average, for example, and I will run the average of this variable, for example. So if the variables are all numerically coded, for example, you notice that all the variables should have some numerical values. For example, here is right. So you see that. So I would definitely say that Eliza in this data file did a good job. All the variables are showing the numerical variables. So this is basically showing the average of each of those variables. But if you notice that one of your variables doesn't shows average is not showing up, for example, let's say instead of 1, Eliza by mistake put down not applicable, or because it's not available, for example, right? And then and then one of the problem is when you notice that if you see that your average is not showing up, for example, I'm just going to go back, put the Eliza 1 for now. If you see the average is not showing up, that's indication that there's something is off is happening in that particular variable. Okay, so before you convert this data file into an SPSS data file, just make sure that there is no funny characters showing up in your data set, like typically, like, you know, some non-numeric letters, for example. If this is a numerical variable, so make sure there is no non-numeric variable showing up, for example, NA not applicable. So if, for example, let's say for this country, let's take Canada, for example, let's say they have last GDP, and let's say it's not available, so do not write NA. Okay, so do not write this NA, for example, right? You leave it blank. Okay, leave it blank like this. Okay, I'm going to put it back number again because this is the number they already have in the data file. But in case if it's not available, do not write NA, just leave it blank. Okay, because if you write down non-numeric character with a numeric character, then it would not allow you to do any descriptive statistics. So you're not able to do any descriptive statistics. So just to recap, get your data file ready in Excel in as clean as possible, no funny characters in the data file, and make sure that your first row, which is your variable names, has only a one word variable name, and of course you can always label them here for more details. All right, so once you're happy with the data file and you save this data file on your computer, university computer, okay, and also on the university computer you will get this SPSS available in university computer. So I will definitely suggest you to do is to use university computer where you can get SPSS. Okay, so once you open up this SPSS, of course when you go university you write down SPSS and it will show you SPSS. For example, like in my computer it is showing up SPSS 26, right? So you might see something 26 or 25 or 27 depending upon what version the computer using lab has. So what I did was I opened up this SPSS. All right, just simply click in and you open up the SPSS, and now what you do is very simple process. Go on the file and say open, okay, and say data. And because we are dealing with a SPSS Excel file, so click on the Excel file. So I click on Excel file, and I'm looking for a data file which Eliza has prepared. So I'm going to look for data file in my folder for this course, and I'm looking for data file which Eliza has created. So here's Eliza's file. Okay, so this is the Eliza has created. So I just opened up, and yeah, as I said, if everything is done okay, then you should be able to see the variable right away, and you see that look like everything showing up very nicely. Basically you can see that, and you can leave all those properties as it is, and I'm simply going to say okay. And you notice that is in the SPSS, look at that, beautiful. So what we did was basically we have transferred Excel file into SPSS, right? And here it is. So this is exactly what we hope to see, and we got here, for example, right? So of course anytime when you bring the data from one software, which is Excel, to another software, which is SPSS, make sure you kind of eyeball your data and see, you know, is there something funny happening. For example, I see that I have this 72 showing up, something wasn't there, so I just simply delete that 72 because it's kind of redundant space. So yeah, so it looks nice here, and you see that it's very beautifully came up on the variable name. And now I'm going to switch. This is a data view. Now I'm going to switch on the variable view. Look at the variable view, right? Look at this one, right? So see all this variable name. This is exactly the same variable name which Eliza created. Here they are, all these variables, right? And you notice that the label is not showing up, right? Which is now super easy. you go back to your Excel, you already have created these variables. In your variables, and simply copy and paste. Simply copy and paste. So now you have a data file which will also contain a variable name. So you see this, nicely done, right? This is very nicely done. It's so super easy. It's not very difficult at all, right? And of course, you can notice that is, for example, one more thing I would suggest to do is just quickly is just go over the measurement of the variables. So you notice that most of the variable ELIZA has are numeric, so they are practically scale variables, for example. But some of the variable, for example, ELIZA has created, for example, you notice the 0, 1, 1 is yes and 0 is no, for example, some of these variables. So what I will do is just quickly, just right now, if you see that these some of this variable, so they are showing up as a nominal. So then basically nominal variable mean that the numerical value of that variable is mostly a placeholder purpose. So 0 doesn't mean it's a good or bad. It's just a value ELIZA has signed, and that's what we did. So what you can do here is this, for example, right now this is election variables, and if you look at this election variable, for example, it's showing up like have they had an election since March 2020, for example. And what we can do is this is we can quickly go on values, and we say, you know what, just put down 1 equal to yes. That's what ELIZA wanted to do, that 1 equal to yes and 0 equal to no. So here is yes, 0, no, right? And if you go back again to election, for example, right, and if you look this called you can value labels. If you click on this value labels, right now it's a code 0, 1. If you click here, you see it's become yes, no. So what we did is we have coded 0, 1 into no and yes, or 1 is yes, 0 is no, right? And this way very nicely it's labeled it for us, because for example, if you want to give this data file to your friend and they probably have no idea what 0 mean or what 1 means, so this way they can see, hey, 1 mean yes and 0 mean no. And because ELIZA has quite many variables like this, for example, so for me, instead of doing for individual variables, I simply copy this this particular coding we just did value. I simply go and paste this one, and this is also same stuff, and this is also same, and this is also same, and this is also same, this is also same, and this is also same, right? Because he's using 1 for yes, 0 for no. And only difference you see here is he has this the leader gender. So here he's using 0 for male, so I'm just going to say 0 for male here, male, and I think 1 he's using for female, and so I'm just going to add that value here, and I just did this one, right? And if you go back to the data view and you play around with this value label, you see this one nicely done, right? So it's a nice value labels. Here it is. So it's nicely done, right? So these values are nominal values, and all other values which is showing up as a scale, because really scale really mean is this, that you can take the average of those variables. That's practically mean. And if you see the variable shows up very nicely, if you see all these variable they have created, they're all numeric, so which I think is a good starting point, because that's what we need now. So this is definitely a very good starting point for to create data set. And of course, if ELIZA want to do more, to create more variable in his existing data set, of course he can create new variable. All you have to do is say insert new variable. For example, here it is insert new variable, and he can say, you know what, I also want to look this variable by continent. You know, perhaps there may be some difference by continent. So that's something ELIZA can do, for example. And what else, and also, for example, like let's say he has this, let's say he has like, for example, let's say recovery rate, for example, he got some recovery rate, right? And maybe he said, you know what, maybe I want to narrow down the recovery rate. Maybe perhaps he decided to do recovery rate in 3 categories, for example. So he can also take this recovery rate variable and create a new variable with 3 categories. So let me give you one example, simple example. Let's say you have a variable, for example, age, right? So people age can go anywhere between, you know, consent adult age can go anywhere between 18 to 18 plus, right? So of course, let's say instead of the country, let's say these are the name of the people, for example, and these and let's say this is age, for example, right? And age can go from, as I said, from 18 to all the way to, like, 100, for example. So you could practically take the age and you can recreate the age into a groups. You can say under 35, 35 to 55, 55 to 65, 65 plus. You see what we did? So we created the age and we created the new categories, and then you can create new variables. So something you can think about, what else can you do with this data set? Can we create some new variables? And answer is yes. So now we have this data set, and what I want to do right now is to run a simple test for you, because now we have this beautiful data set, and just see can we do some simple analysis. So let's look at this variable they have here. It's called wing leader. So they also have wing leader. So we can also define wing leader here. So there is also one is for left wing, and I'm sure when this team will do some data analysis, they explain what really left and right mean, because some of people might not know, like some people who don't know this political jargons, so they might able to explain what left right really mean. So I'll leave this to the group. So I think this is also a good point for me to just quickly say that anytime when you do data analysis, you should have some sort of a knowledge what these variables are. Let's say if you're presenting these results to a meeting, to a conference, for example, the expectation is that you know your data, you should know values of those data, you should know those variables, what this variable represent. Okay, so that's very important. It's not just having a data file set up, but it's also have some sort of a background knowledge as well. So, and that's what implies that. So let's say for example, let's look at this. Let's look at the death rate, for example. Okay, and you want to find out does the death rate and a political leadership has to do some sort of relationship, right? Find out, right? So what I want to do is I want to do a test, and so we have two groups. We have a left and right. So we're talking about two samples, for example, and then our outcome variable is, let's say, is the death rate, right? So of course your null hypothesis is that there is no difference between these two groups. That means the death rates are same in both political orientation. But of course you could also set your alternative hypothesis that no, there is a difference between these two political ideology, for example, left or right wing, for example. So watch carefully how you do this two sample test, which is super easy. Go and analyze, okay, and compare means, and go independent sample t-test, okay, and click here. And so first of all, we want to find out our the death rate variable, the test variable. So I selected death rate variable, for example, and then next thing we're looking for this political ideology variable, for example. So here it is, left right. So select the grouping variable, right, and then of course we have 0 for the left, and then we have the 0 for the right, and 1 is for the left. That's how he assigned this group. Okay, so that's what we do. So what we're really doing is just we try to comparing the death rate by the political leadership. 0 is for the right wing, and the 1 is for the left wing. Okay, 0, 1. And yeah, so that's how you define, for example, two groups you're comparing them. So you say continue, for example, and that's all you have to do, and you simply say okay. So you say okay, and you got this result here, for example, right? So all right, so let's look at this number, for example. So you see that here, this is the result. So this is what you're seeing is the average. So this is this is in percentage, by the way. So they're saying that for the right wing, the death rate was about, here it is, you can see this number here. So this is the number, this is about, so this is in percentage, about 2.36%, right? You can say about 2.4 if you try to round up these numbers, for example. Okay, and you can see the left wing is 2.69, so about 2.7%. So you can see that the death rate for the leadership which are on left wing has a slightly higher death rate, okay, compared to the right wing leadership, for example. All right, so you can see that the left wing has, but of course one of the question, as I've been saying all along, sometimes average mean nothing, because we also have to know whether it's significant difference or not, right? So so based on this number, it look like the left wing has slightly more death rate than the right wing in percentage, okay. But this is the bottom output is your t-test results, okay. And if you listen to the lecture on comparing two samples, so there's a two assumption we made: equal variance assumption and equal variance not assumption, for example. So how do you really identify which one to use, for example? So this is called Levine test for equality of variance. So this is a p-value for the Levine test. So for example, so this is a p-value. Sig value is a significance value, so p-value. So this p-value is more than 0.05%, right? So because this is more than 5%, so we do not reject this. We say, okay, for this test we're going to use equal variance assumed. However, if this value were less than 5%, then we would have accepted this alternative, which is equal variance not assumed. Because this is more than 5%, equal variance assumed is accepted. All right, so therefore, so this is a t-test results, right? And this is a p-value for the t-test, right? P-value t-test. And you can see that the p-value for the t-test is 50%, is more than 50%, right? And so what does it mean? Because this is not a less than 5%. So our conclusion is even though the left wing has slightly more death rate than right wing, but statistically there is no significant difference between these two groups. That's the result. The result is this, that the political leaderships, the difference is not statistical significance. In other words, statistically speaking, the difference is not significant. And because difference is not significant, I will definitely ask this group, for example, okay, so find out, is there an outlier? Is there some extreme numbers? Because that will be very interesting if you try to look at the extreme numbers, for example. And let's go back to this t-test one more time here. So this is a t-test result, and this is a p-value we use always. This is a p-value. And I also talked to you about the confidence interval. If you look at the confidence interval is between, the difference is between these two groups are between 13.85, so about 14% to 7%. But if you notice that between negative and positive, the 0 is there, and because in this interval 0 is present, because you see that one number is positive, upper is positive, lower is negative. So therefore we do not reject the null hypothesis. That's what really means. And that's pretty much your t-test is. So give it a try and get your, first of all, get your Excel file nicely organized. Okay, no funny characters, very simple. This is exactly what this group did. And I asked the permission if I can use the data file for demonstration, and they said, yeah, I can use this. So you see this is very nicely, simply done. And then you bring the data file into SPSS. This is what I did here. Follow the steps. You can rewatch it again. And of course, if you have any question, feel free to reach out to me, and definitely utilize my office hours and come and talk to me. I can definitely give you guidance and help. Bye.